as we're discussing, we said one side effect of the carbonic anhydrase inhibitors is loss of what potassium, or it can lead to hypokalemia. Someone will ask, how does this drug lead to hypokalemia? If we are preventing the reabsorption of sodium at the proximal tubule, what is happening is that then we are pushing sodium to the distal and collecting tubules. And any diuretic that increases sodium loss up to this point of the kidneys or the nephrons will lead to loss of what potassium. And the question is how? We know that at the collecting tubules, most of the time sodium is mostly exchanged for what? Potassium. Sodium is mostly exchanged for potassium. And let's see something over here. If I'm expected to extend the cells over here, at the luminal side of the distal convoluted, at the collecting tubules, at the luminal side, or at the principal cells of the distal convoluted tubule or the collecting tubule, this is what is going to happen. We have sodium channels at the luminal side of the collecting tubules, and we also have potassium channel at the luminal side of the collecting tubules. And what are these channels doing? What are these channels doing? The sodium channels over here constantly pick sodium, pump it into the cell. And as I said, at the basolateral membranes of every cell, we have the sodium potassium pump. The sodium potassium pump constantly takes 3 sodium and pump it and bring what? 2 potassium inside the cell. So the sodium that will be reabsorbed over here will be taken out into the cell, and when it gets into the cell, because of the sodium potassium ATPase pump over there, the sodium will be also be pumped back into the blood. Are you okay? And when sodium is pumped out of the cell, we get what? Potassium, and the potassium that we also get will also start leaking over here. So when you give the carbonic anhydrase inhibitors, it increases the potassium load up to this point, and when the potassium load, it increases what? The sodium load up to this point. And when the sodium load is increased and we get here, sodium that is coming, part of the sodium will be what? Reabsorbed. And when sodium are reabsorbed at the collecting tubule, they are what? Exchanged for what? Potassium. And the other thing is that at the proximal tubule, we are only not losing sodium, we are losing what? Bicarbonate. Bicarbonate is what? Negatively charged. Bicarbonate is what? Negatively what? Charged. And because of the negatively charged, it creates an electrical gradient over here. So because of the negativity over here, it will attract what? Positive ions. And potassium is what? Positive ions. So we are going to what? Lose more potassium because of what? The change in what? Gradient. Are you okay? So aside this channel taking in sodium, the change in gradient will also cause loss of what? Potassium from the cell into the nephrons or the tubules. Then we lose potassium in addition to what? Bicarbonate and what? Some aspect of what? Sodium. So this is how maybe the carbonic anhydrase inhibitor will lead to loss